Hi, my name is David Rice, and today I would like to walk you through a simple demo using IBM Open Data Analytics for z/OS. The purpose of this demo is to showcase how easily data can be analyzed in place on z/OS, or as some of you may know it, the mainframe environment. Many of our large enterprise customers run their core business operations on z/OS, and these processes generate a huge amount of high-value data. Analyzing data at the source gives our clients a competitive edge in their respective industries. In this demo, we will be pretending we are a data science team for a bank that has experienced a client retention issue, or as data scientists like to call it, customer churn. The data we are using is a sample set of customer information and credit card transactions. So let's start up the client retention demo notebook. We are running this Jupyter Notebook server on z/OS, so all work will be done on the mainframe. In this demo, we are using a special library specific to IBM Open Data Analytics for z/OS called DSDBC. DSDBC accesses data via the Optimized Data Virtualization Layer component of IBM Open Data Analytics for z/OS. This layer reads various data types like DB2, vSAM, IMS, physical sequential, as well as many others, and makes a virtual table of its contents. It then exposes it to DSDBC as if it were a database table. We are also importing a few of the industry prevalent Python packages, Pandas and NumPy. Now that we've imported those libraries, we will load a vSAM file containing client information into a Pandas data frame using an SQL statement. Next, we will load a vSAM file containing credit card transactions into a Pandas data frame, also using an SQL statement. Some of this data that we've loaded is not formatted into the correct types, but with a few simple commands we can fix that. Next, we will create a new feature called Date, which will help us with a few of the statistical analysis we will be doing later on. Now that date has been created, it is time to calculate some aggregate statistics. We will be computing the total number of transactions per customer, the total amount of transactions per customer, the average transaction amount per customer, and the average daily transaction per customer. On some of the days, the customers didn't make credit card transactions, so they will end up with not a number errors. We will quickly remove those entries from this list. We will also join those stats back to the client table and take a quick peek at the newly added features. Next, we will import another set of industry prevalent Python packages, matplotlib and Seaborn. This import will fail because matplotlib is not installed. Using Anaconda, let's install it. First, we will show that it is uninstalled. We will then install it and then confirm that it is installed. Now that matplotlib is installed, let's rerun the failed cell to import matplotlib and Seaborn. This is just a quick way to show how easy it is to install Python packages using the Anaconda environment on z/OS. Now that matplotlib and Seaborn have been imported, let's do some exploratory graphing. The first graph is simply showing the relationship between the age of the customer and their annual income. Next, since we are trying to show the features that relate to customer churn, we will create a heat map with the various features and see what relates to churn. There are two features that are strongly inversely correlated with the customer churn, being the customer's age and the customer's activity level. So the younger the customer is, and the customers who interact with the bank less, are more likely to churn. Now that we have that insight, let's focus on the customer's age to see what groups seem to be churning the most. The 20 to 25-year-old bracket is churning at a pretty high rate. There's also a smaller churn peak at the 40 to 45-year-old bracket. This box plot will show that there's a relationship between the customer's age and their activity level, basically showing the younger people are less likely to interact with the bank, which based on our previous insights makes sense. This B-swarm plot is showing the same type of information. The younger people are less active and are the most likely to churn. Next, we will import another industry prevalent Python package, scikit-learn. This package contains a multitude of machine learning algorithms In our case, we will be using Random Forest Classifier. First, we will prepare a few methods to help train the model, and then we will train the model. Now that the model has been trained, let's do the most important part of this entire demo and calculate the business loss. We will first set up a few helper methods, then run our trained model with our data to get a predicted loss of each customer. We will then group our customers by age, calculate the predicted loss per group, and then graph this out. Notice, the 20 to 25-year-old group is not only the most likely to churn, but also the biggest business risk. So if this bank wants to improve their business, they need to figure out how to reach the younger demographic. The point is, with minimal effort, I was able to scan through a pretty large set of data and figure out a pretty major business risk. This of course isn't a solution to that problem, but it does show where the business should be focusing its attention. Once a better solution is in place with how to handle this demographic, you can use this same set of frameworks to efficiently and quickly aggregate and distill this high-value data for downstream analytic processing and integration across your environment. So, for example, you could take the model you trained it in a notebook and have it evaluate transactions while they happen. This would prevent the data from becoming stale as it is sent to a data lake. Again, my name is David Rice, and thank you for watching.